Thanks, Deborah and Trevor. Yeah, so Trevor just kind of outlined just a ridiculously amazing amount of testing that's going on in a whole different bunch of environments. I'm going to narrow in very specifically on two of those testing events, specifically because this is really where we hit the science operations really, really hard because we have, as I'll explain, full integrated SMD competitively selected science teams. Next chart, please. Okay, so right now, hopefully today and past LSSWs have shown you that we are making significant progress in defining the architecture, the infrastructure, the roles and responsibilities by which we'll integrate science into Artemis. To do this, I'm going to talk about how Jet 3 and Jet 5 fit into this process. Jet 3 was the highest fidelity Artemis EVA mission simulation ever conducted, following the Artemis 3 mission plan as closely as we could, and Jet 5 will build on from there. Both Jet 3 in the past and Jet 5 in the future will include a full EVA flight control team as well as a competitively selected science team out of SMD Roses in both the pre-mission and the mission execution phases. And critically, Jet 3 lessons learned are already feeding really critical Artemis development areas like hardware development, facility development like the science back room, roles and responsibilities definition, competitively selected calls like the A3GT and the payload calls. So these tests are really instrumental in paving the way for successful science exploration during Artemis. Next chart, please, Chelsea. So Jet 3, a quick overview of what it was conducted back in October 2022. We executed 4 EVAs that were planned to be 4 to 6 hours in duration. We used 2 different EVA mock-up suits. Some were the backpacks like you see in the middle right, and then some were a more robust mock-up suit like you see in the lower right. The Jet 3 mission planning process was consistent with what we know to expect for Artemis. The science team, and I'll go into more details, generated science priorities and prioritized science stations, and then the EVA flight control team with science input planned EVAs around those science priorities and additional test objectives. We had a field team that was executing on the field side, and then an MCC team that included the EVA flight control team and a full science team. Next chart, please. So I'm going to talk briefly about the pre-mission workflow, which included defining science objectives, onboarding and training the science teams, and generating our science deliverables. Then I'll talk about mission execution and how we executed the 4 EVAs, and then talk a little bit about moving forward and into Jet 5. Next chart, please. Okay, so first we'll talk about the pre-mission phase, which is when we developed the science deliverables that fed the Traverse plans. Next chart. So first we onboarded the SMD competitively selected science team, brought them up to speed on what we were doing with the exercise. We then had a couple working meetings to orient and discuss the exploration area that we were given by the test team. The science team then completed geologic mapping at multiple scales before defining our science questions and formulating a science traceability matrix. We then worked to define stations and critically to prioritize those science stations, which were then merged to create our 4 EVA traverse plans for the test. We then fed the development of ops products, or products that the crew had in their hands during the completion of the EVAs, to help them remember what the traverse plans and the science objectives were. Next chart, please. Okay, so we also trained the science team. Of course, we had this really wonderful, robust, competitively selected science team come on through Roses, and we wanted to bring them up to speed so that they could execute during the real-time mission execution. We did this kind of through both virtual trainings and through an in-person event. Virtually, we conducted lessons on flight control team structure and everything they needed to know prior to arriving for the test. We also completed a training dry run at NASA Johnson Space Center, where we gave the science team tours of critical facilities. We gave them briefings on being a flight controller and sitting in the science back room, and we critically conducted a mini simulation event. For that mini sim event, we gave them traverse plans and ops products. We had test subjects actually executing in a VR environment last year that included a 2-hour traverse followed by where we had the science team actually in the science evaluation room, followed by debriefs. We then also had a training day where the science team delivered science training to the crew and the flight control team, and then received training on just the overall test structure. Next chart, please. Okay, so then we went to execute the mission, which was in October of last year. Next chart, please, Chelsea. Okay, so here's the flight control team structure that we are planning for Artemis surface missions down in the lower left. So we have the FICR, the flight control room, the main front room, where you have in the EVA flight control team, the flight director, the lead EVA officer, and the person talking to the crew. You then have the MIPSR, the multi-purpose support room, where you have critical EVA functions like a systems person responsible for the health of the suit, the task person responsible for the tools and the timeline and navigation constraints, and then our new flight controller position for Artemis, which will be the EVA science officer. Each one of those positions was backed up for Jet 3 by at least one backroom function. For science, this is the science evaluation room. This SIR was staffed by our awesome competitively selected science team, as well as some other NASA internal representatives who were really attempting to direct the crew to accomplish our science objectives. Next chart, please. The SIR, or the Science Evaluation Room, is the room where science teams will operate during Artemis missions. They'll be providing real-time science feedback as well as strategic science oversight over the mission. We do have a requirement, Sarah mentioned this earlier, to be in close physical proximity to the rest of the EVA flight control team. And actually the Jet 3 results helped generate requirements for what the Artemis SIR needs to look like that have already been delivered. And as Sarah mentioned, we have a space in the main mission control facility that is going to be developed to meet these science team requirements. For Jet 3, we had a certain number of roles that we populated in the SIR. I won't go over them here in the interest of time, but we had some great iterative discussions feeding forward from that mini sim training event on what we wanted the SIR to be structured like and how our daily schedule was going to be completed to execute mission operations. Next chart, please. Okay, so here's just some pictures. We had the science evaluation room highlighted in red where we had the SMD science team stationed on site at JSC. We also had our EVA science officers who were sitting in that EVA MIPSR I mentioned earlier. We had NASA headquarters representation there to observe and get experience and help us make sure we're being as extensible to Artemis as possible. And then we also had some of our science team in the field to track what the crew was doing on the ground, which was a really critical part of our lessons learned generation to be able to provide that ground truth answer key from our field science team. Next chart, please. Okay, so what's next? Jet 3 was really instrumental in developing requirements and lessons learned that are already being implemented across Artemis, but obviously the work does not stop there. Next chart, Chelsea. Okay, so the full test team for Jet 3 and the Jet 3 science team generated a series of reports that are already being implemented in several really critical ways. A main example of this is that the Jet 3 results really informed the requirements for the physical room layout for the Artemis SIR, which is already being implemented in development now. We were also able to develop plan, train, fly workflows with scientific insight that are being implemented across Artemis. For example, when the Artemis 3 geology team gets on board, we know that the results of these tests are going to help inform immediately some of the activities that team is going to be contributing to. But it doesn't stop there. Of course, we're also planning for Jet 5. It's currently planned for this fall. We had another Roses Call that competitively selected an additional science team for Jet 5. That team is on board and the science team work is underway. In case you're wondering what we're up to this week, we're working on geologic mapping and we're having some splinter meetings to generate a science traceability matrix for our landing site. We have a number of objectives, a whole lot of objectives, frankly, for the flight control team and the science team, but a couple critical ones I wanted to highlight for you, where we do plan to implement 2 operational shifts for Jet 5. This will include like the execute shift or the tactical shift, the shift that's staffing the science evaluation room when the EVAs are being conducted. And then we will also integrate a planning or a strategic shift that works essentially when the crew is sleeping to integrate our science priorities and potentially, as we were talking earlier after Caroline's talk, integrate small tweaks we plan to make to the traverse plans for the subsequent days. We also plan to really hit the operations products necessary to support 2 shifts. How do we pass off science knowledge, lessons learned? We know past analog tests have done this and we plan to data mine from those as well, but we look forward to developing new ops products in the context of what we know about Artemis. We also plan to use Jet 5 to validate requirements that we already delivered for the SIR, the roles and responsibilities that we've defined that for the scientists that will sit in the science evaluation room. We have some science software development development objectives that are going to validate new software that's being developed internally to support Artemis. So we have a lot of really critical and exciting SMD objectives, all of which track back to that report that Amy Fagan mentioned earlier, the Analog Objectives for Artemis report, which is, of course, SMD's latest and greatest gaps for what needs to happen before Artemis surface missions. Next chart, please. Okay, so in conclusion, Jet-3 was the most robust Artemis EVA mission simulation ever conducted. We had a fully integrated science team into the EVA flight control team, both before the mission and during mission execution. And just a note, I don't think I need to convince anyone on the line here, but Jet-3 scale tests are absolutely vital in preparing hardware, our operations structure and infrastructure, and our science communities for Artemis lunar surface exploration. Jet-5 is planned to close remaining Artemis 3 gaps. And just a note, to echo what Trevor said, science is fully integrated here and in this picture into Artemis flight operations, and we're looking forward to Jet 5. Thanks.